Welcome students. Let's see the topic Wood's concept, that is data abstraction. We can define it in a simplified manner, that is only focusing the interested features and hiding the uninterested features from the user. That is called data abstraction. So data abstraction becomes an abstract data type, ADT, or a user defined type. So abstraction is referring to the representation of necessary features without including the detailed explanation. So data abstraction is a programming technique that relies on the separation of interface and the implementation of the program. Let's see the example. So in a normal way, while you are going for executing the program, we will feed some input to the program, then execution will be processed, and finally we will be getting the output. So the user will be focusing on what is the output we are getting at the output side. They won't bother about how the program is executed, whereas the data is hidden and also the implementation part and the background details all will be hidden from the user. That is called data abstraction. Okay, let's see a real-time example for data abstraction example. When you press the key on your keyboard, the character appears on the screen. You need to know only that how exactly it works based on the electronically is not needed for the user. So this is called abstraction. Another example, when you use a remote control of your television, you do not bother about how pressing the key in the remote changes the channel on the TV. If you are going for pressing a plus button, that is volume button, it will automatically increase the volume. So the user won't bother about the internal changes, electronically changes in the television. That is abstraction. The next concept is encapsulation. See this picture. So here there is a capsule. Inside that you are having some data. So this is a capsule like tablet. This is methods and variables are combined together in your full capsule form, that is class. So class is a concept which is the best example for the encapsulation concept. So encapsulation is the first pillar or the principle of object-oriented programming. In simple words, we can say encapsulation is the process of binding the data members and the member functions into a single unit called class. So data members means the variables. What are the variables you are using inside the program, and what are the properties you are going to set for the program. And member function means methods. There is a task you are going to do with the help of the data that operate on the data. So encapsulation means hiding the important features of a class which is not being needed to be exposed outside of a class and exposing only those necessary things of a class. That is called encapsulation. So we are going to have two concepts. One is encapsulation and abstraction. So encapsulation is hidden part of the class acts like the encapsulation, and the exposed part of the class acts like the abstraction. What is data hiding? Data is not accessible to the outside world and only the access method within the class. This process is called data hiding. Let's move on to the next concept. Wood's concept is inheritance. So it's defined as the mechanism of deriving a new class from the another class is called inheritance or derivation. Inheritance is a mechanism which provides the power of reusability of code and the extendability of the code. So inheritance is a process by which one object can acquire the properties of the another object. So we can extract the features of one class to another class. So the old class is called base class and the new class is called derived class, otherwise called a subclass. Okay, it's a powerful feature of Woods. For example, consider a family having 3 members, father, mother and son named Jack. So Jack father is having the property tall and dark, and mother is having the property short and fair. So Jack's son is having the tall and fair. So he is said to have the features of tall property from his father and fair property from his mother. So inheriting the features from father and mother. Here is the pictorial representation. For example, inheritance, grandfather, father and child. So child will be acquiring the properties of father as well as the grandfather. Okay, here is the common parent class is vehicle and the subclasses are car and truck. And electric and petrol are the subclasses of the car. So electric and petrol acquire the features of car. Car and truck acquire the features from the parent class vehicle. So another example, point and line. If you are having 2 points, from the 2 points you can draw a line. So point is the parent class or base class and line is the child class or derived class or subclass, acquiring the features from the parent class point. So what is the main benefit of using the inheritance? It saves lot of time in your programming and also reduces errors. So which in turn will increase the quality of the work and as well as the productivity of the work. So there are 4 different types of inheritance. The first type is single inheritance, second type is hierarchical inheritance, third one is multiple inheritance and fourth one is multi-level inheritance. We'll see the different types in the later classes. The next concept is polymorphism. Poly means many and morphism means many forms. So which is the Greek word. So from this figure you can identify that the different entities or objects giving different sound. So sound is a common one. Based on different object it produces corresponding the different objects. So we can define polymorphism as ability to take more than one form. For example, plus is an operator which takes 2 different forms. That is, addition is one form and it performs the operation of combining the 2 strings. So this is called operator overloading because the same operator may behave differently on different instances. So polymorphism, the same way functions can be also overloaded. For example, sum is a function. It may take 2 arguments and 3 arguments. Sum of 5, 7 is taking 2 arguments and sum of 4, 6, 8 is taking 3 arguments. Okay. Another example, print is a function which draws different objects. Print is the function which is used to draw the circle, rectangle, star, different shapes. So the similar example also picturized here. The next concept is dynamic binding, which is nothing but linking of the function call and the code to be executed. That is, binding means linking of between the call, function call and the code. So it is the process of linking the function call to the actual code of the function at the runtime. So why we call it as a dynamic binding is that the compiler will not be knowing until the runtime that is the actual code to be executed. So it is also otherwise called as late binding is otherwise called as dynamic binding is otherwise called as late. The next concept is message passing. So the objects can pass the message to different objects. So objects can communicate with each other by passing the message as people passing the messages with each other. The object can send or receive the messages or information. The message passing involves the basic steps. First step is creating the classes that define objects and their behavior. Second step, creating the objects from class definitions. third step, establishing the communication among the objects. Okay, the concept of message passing makes it easier to talk about building systems that directly model or simulate the real world counterparts. Here is an example. Here two classes are there. One is the product class and the other one is the order class. The product class can communicate with the object of the order class by sending the request for placing the orders. So here order 1, place order, passing the parameter quantity in hand. Is order 1 is the object name and place order is the function or the message, and quantity in hand is the information that is passed. It's an optional one. Okay. So here it's another example, student object, faculty object and management object. They are passing the messages through the functions. So what is the benefit of object-oriented programming? So object-oriented system can be easily upgrade from the small system to large system. So it is easy to partition the work for the same project. For example, if a person is assigned a project, under this project 3, 4 or 5 members under this project. So each person will be doing a different task. So at last each task or the module will be integrated to form a single project. So message passing techniques makes the communication between the objects in an easier manner, and software complexity can also be easily managed, and maintenance cost is also very less and simple to implement. And what are the areas where which we can apply the object-oriented concepts or real-time system, simulation, modeling, object-oriented databases, hypertext, hypermedia, expert text, artificial intelligence and expert systems, neural network and parallel programming, decision support system, office automation system, CIM, SCAN, CAD systems. In all these areas, we can go for applying the object-oriented concepts. And these are the references used for the presentation. Thank you for patient listening. Thank you, students.